Good morning, everyone. Welcome back. I hope you guys had a nice few days off. We're going to jump right into the rest of our trig unit, and this will actually be one of the last few lessons that we have. This lesson is going to take 2 days, so you can pace it however you want. I put the suggested pacing guide on your Google Classroom assignment. You should take the first day to watch the video and take the notes. And then I have an ongoing doc that you can post questions in and answer your classmates' questions. And then the second day, you're going to complete the practice problems, check your work, and do the exit assessment and submit that as your assignment. If you want to do it all in one day, that's perfectly fine. You can do that. But just make sure you have it all done by the assigned due date. All right, so today we're going to be working on word problems with trig. So we have these types of angles called angles of elevation and depression. And we kind of need to go through what these mean and how you can draw them before we could actually start with some example word problems. All right, so just take a minute, try these 3 example problems, a review of finding angles and finding side lengths. When you're done with them, come back and check your answers. Okay, so just a quick reminder of how to do these. So first, I always circle the reference angle, and that would be the acute angle that's labeled. Our right angle cannot be our reference angle. And then we label the sides that have markings on them. Okay, so I'm not going to label A, B because there's nothing on it. Now, a lot of you guys are mixing up your opposite and your adjacent. Your adjacent is the side that's right next to the marked angle. So since AC is touching this marking of theta, that would be our adjacent. The other side that's not touching it at all, if I trace over BC, it's not touching that angle. That would be our opposite. So we remember we have SOHCAHTOA. O and A is tangent, so I'm going to set up tangent of my angle is equal to opposite over adjacent. Since we are finding the angle in this one, we have the inverse tangent of 10 over 13. So remember, on your calculator, you hit the second button, then tangent, and we end up getting, make sure your calculator's in degree mode. We end up getting, mine's not in degree mode, give me a second. We end up getting 37.6 degrees. Okay? All right, let's take a look at number 2. Circle your reference angle. I've got my hypotenuse and I've got my opposite. So that means I'm going to set up sine of 75 equals my opposite over my hypotenuse. Okay? I'm going to multiply both sides by x to get rid of the fraction. And then to get x by itself, I'm going to divide both sides by sine 75. And then when I plug that in my calculator, we get 6.2. And this is not an angle, so I'm not putting degrees. All right, last, number 3, circle your reference angle. We've got our opposite and our adjacent. So that would be tangent equals 16 over 4.7. We're going to do inverse tangent. And we get 73.6 degrees. And that one is an angle, so we are going to put degrees. Okay? All right, so now you could either print out the notes or take out a separate sheet of paper, and we're going to get started on angles of elevation and depression. Okay, so angles of elevation. Let's say we have a lighthouse. Don't mind my terrible drawing of this lighthouse here, okay? We have a lighthouse, and then we have somebody that's standing on the ground looking to the top of the lighthouse. Okay, so their eyes are looking at the top of the lighthouse, okay? This line that connects the person on the ground to, or the object on the ground to the object that's in the air or taller, the top of the object, whatever it may be, is called the line of sight. Okay, and the angle of elevation is created by the line of sight and the bottom horizontal. So we've got the lower horizontal. So where these two things meet, that would be our angle of elevation. So this right here is our angle of elevation. Okay. The object that's taller or higher off the ground or whatever it may be is always going to meet the horizontal lines at a right angle. So this is where your right triangle is coming from. We've got the line of sight, which is always going to be the hypotenuse. So that might be something important to write down. The line of sight is always going to be the hypotenuse. And then the two objects, or the lower horizontal and the object that connects kind of the top of the taller object or the ground to the taller object, whatever it may be, that is going to be a vertical line. Okay, so you're just going to have your right triangle. It's drawn the same exact way, so on and so forth. Okay, so usually we use angles of elevation when you are talking about someone looking up to the top of an object or looking up to an object in the sky. It opens up, elevate, open up, okay? Angles of depression are a little bit different. Angles of depression take place when we have an object in the sky or somebody's at the top of something and it's looking down to something on the ground. So a common example of angles of depression are airplane problems. Don't mind my terrible airplane, okay? So we've got an airplane, and then let's say we've got the runway down here, all right? So if we say that the angle of depression is from the airplane down to the runway, instead of using the ground as the horizontal, we're going to be using the sky as the horizontal. So we still draw in our line of sight from the upper object to the lower object. And again, that's still going to be our hypotenuse. Line of sight, hypotenuse. Okay. But now I need to draw in the sky as the upper horizontal. So we've got our horizontal line up here. Okay, so now this would be our angle of depression. Okay, so depending on how you're going to draw this triangle, your angle of depression could be in this triangle that's on the right. And let me try to highlight this over here so you guys can kind of see what I'm talking about. So if you have your triangle drawn over here, that's fine because your angle of depression would be in the triangle. But the way that I tend to do these problems is I still draw my triangle over here on the left side. Sorry, that's a bad line. Okay, so then in order to find this angle that's actually in the triangle, you would do 90 minus your angle of depression. Okay, that looks a little bit confusing, but it'll make more sense when we do some examples. Okay? All right, so just a quick intro of how to draw the angle of elevation, the angle of depression. It'll make a little bit more sense as we go through some practice problems. So hold your questions for the time being. See if you can get through some of the examples. It might click a little bit easier. Okay, so first problem. Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So this 6 feet tall is important because Casey's eyes aren't on the ground. Now, technically his eyes aren't directly at the top of his head, but it's going to be a rough estimate, so we're just going to assume that his eyes are at the top of his head. So we can kind of use the way that the example is drawn to help us. So we've got Casey standing on the ground. We've got our lighthouse. Sorry for my awful drawing. Okay, so now let's draw in our line of sight. So line of sight to the top. And then we draw over our horizontal. Okay. All right. So if you notice, our right triangle is kind of floating above the ground on this one. So the angle of elevation would be this angle right here. That is 58 degrees. And then the other part that's important is that Casey is 6 feet tall. Okay, Casey is 6 feet tall. The lighthouse is 84 feet tall. So this is 84 feet, but this part right here is 6. So when I redraw my right triangle, this vertical line is not 84 feet. It's going to be 84 minus 6, which is 78 feet. So when we redraw this over here, 58, okay, again, it would be the top of the entire height of the lighthouse minus Casey's height, okay? Because again, I'll show you here, this does not go the entire length of the lighthouse. It's not 84 feet tall. The triangle starts 6 feet above the ground. Therefore, we're only going to use a height of 78, which is 84 minus 6. And then we're looking for how far is he standing from the base of the lighthouse. So that would be the horizontal line, which is X. So now we just go about solving this like we normally would. Circle your reference angle. I've got my opposite and my adjacent. So that would be tangent. Tan of 58 equals 78 over X. I'll multiply both sides by X to get rid of my fraction. X tan 58 equals 78. And then I'm going to divide by tan 58. And then we get X equals, let's see, 78 divided by tan 58 is 48.7 feet. And since we're doing word problems, you should always have a unit of measure now. Okay? All right. Let's try number 3. Skip to number 3. Leah's mom is standing at the bottom of the slide at the playground waiting for Leah to slide down. If the angle of elevation from the bottom of the slide to the top is 46 and the slide has a vertical height of 9 feet, find the length of the slide. Okay, so let's draw a slide first of all. So we've got this nice little slide here. Okay. The angle of elevation from the bottom to the top of the slide is 46 degrees. So let me trace over this. So we've got our horizontal, we've got our vertical. So this is our right angle here. And then the length of the slide is actually our hypotenuse. The angle of elevation from the bottom of the slide to the top of the slide is 46 degrees. So that would be that part right there. So we've got 46 degrees. And the slide has a vertical height of 9 feet. So this right here is the vertical height. So that would be 9. They want us to find the length of the slide, which would be the hypotenuse. So here we go. Circle our reference angle. We've got opposite, we've got hypotenuse. So sine of 46 equals 9 over x. Multiply both sides by x to get rid of the fraction. X sine 46 equals 9. Divide by sine 46. And we get the length of the slide is about 12.5 feet. 12.5 feet. Okay? All right, so now try the other two and then come back and check your answers. All right, so number 4 is a little bit different. So it's already drawn out for you. But the reason number 4 is a little bit different is because they are asking you to find the angle of elevation. So the only difference is you're now using inverse trig instead of regular trig. So I've drawn the problem. The dog is standing 5 feet away from the base of the tree, so that's the horizontal, and the cat is 16 feet in the air or in the tree, so that's the vertical. Okay, so then we're looking for the angle of elevation. So we've got our angle, our reference angle, we've got opposite and adjacent. So we have tan of x equals 16 over 5. Since we're finding an angle for this one, you're using inverse tan of 16 over 5. So hit that second tangent button, 16 divided by 5, and we get 72.6 degrees because, again, this is an angle, okay? And then take a look at number 2, check your work, see if you got the same answer, all right? All right, let's move on to angles of depression. Okay. So number 5 kind of goes along with the diagram that's drawn up here. We've got a lifeguard sitting on a platform looking down at a swimmer in the water. The lifeguard's line of sight, meaning his eyes, are 8 feet above the ground. And the angle of depression to the swimmer is 18 degrees. So let's draw this. He's swimming, I promise. He's not floating. Okay. So the line of sight is up here. And then remember, the angle of depression is created with the upper horizontal. The upper horizontal, which is, 18 degrees. Okay. So here's where the tricky part is. It says that the line of sight is 8 feet above the ground, and the angle of depression, how far away is the swimmer from the lifeguard? Okay, so now if we look at this triangle here, okay, we know that he's 8 feet above the ground, and we're trying to find this distance, x. So the angle that they gave us is actually outside of that red triangle. Okay, but it's really easy to find the angle that's inside the red triangle. The angle that's inside the red triangle is just 90 minus that angle that's outside. So if you're trying to find the angle that's inside that triangle, it's 90 minus 18. And we get 72. Okay, so we have 72 degrees. Okay, so now let me redraw the triangle that we're working with. We've got 72 degrees. We're looking for the bottom horizontal, and we have the height. So that means, circle your reference angle. We have the opposite and the adjacent. Tangent of 72 equals x over 8. We're going to multiply both sides by 8 to get rid of the fraction. 8 tan 72 is equal to x. And then we get 24.6 feet. And that's how far away the swimmer is from the lifeguard. Okay? All right, let's take a look at number 7. Number 7's a little tricky. Building A is 480 feet tall. And building B is 654 feet tall. Okay, so this height is 480. And this height is 654. So then it says, and I'm going to do this in another color, the angle of depression from the top of building B to the top of building A is 42 degrees. Let me label these. A, B. Angle of depression from the top of B to the top of A. So remember, angle of depression is going to be outside. So this is 42 degrees. I want to know how far apart are the buildings. Okay, so we can actually figure a couple of more pieces of information out here by using this diagram. So first of all, I want to use this triangle. Okay, that's the right triangle that I want to use. Now remember, this 42 degrees is outside of that triangle. So let me actually highlight in red the triangle that I want to use. So in order to find this angle that's in here, we could do 90 minus 42, which gives us 48 degrees. So let me redraw this over here. We get 48 degrees. That's going to be our reference angle. Now, we can also, and I'm going to highlight this in yellow, we can figure this height out as well, okay? Because what we're looking for is the distance between the two buildings. And in order to find that distance, we need to have one of the other sides. So the way that we could figure out this height that I've highlighted in yellow is by subtracting the heights of the two buildings. So I know that from, this would be 480 because that's the height of the smaller building. So then to find this height here, we're just going to do 654 minus 480, which gives us 174. So this height is 174. Now we can just go about our normal business. Reference angle, opposite, adjacent. So we have tan of 48 equals x over 174. Multiply both sides by 174. We get 174 tan of 48 equals x. And the distance between the two buildings would be 193.2 feet. Okay? All right, I want you guys to try 6 and 8 and then come back and check your answers. All right, here's the answer for number 6. Just so you guys know, the altitude is just another word for height. So take a look at number 6, check your answer. We have the angle of depression is 73, so that means the angle that's inside the triangle we're using is going to be 17. And here we have the answer for number 8, okay? Now, the thing about these problems is that the hardest part is drawing the diagram. So if you're having a little bit of trouble drawing the diagram, write down which number you had a problem with on the Google Doc. Hopefully myself or one of your classmates will be able to answer it. But once you guys have the diagram drawn, the solving part is pretty simple. It's just like what we did the past few lessons, okay? So that's it for today. If you have some time and you want to start some of the practice problems on the next page, I have 10 practice problems for you. You could do some of them. You could do all of them if you really want the practice. It's up to you, but I'm going to post the answer key for that. And then when you have time, you can work on your exit assessment and submit that as well. Remember, you have 2 days to do this lesson, okay? So if you don't finish it all today, that's fine. Don't rush through it all. If you want to take the time to work on the practice problems on the exit assessment tomorrow or the next day, then you can do that as well. As always, if you guys have questions, just shoot me an email and I'll be sure to get back to you as soon as I can.